we've got g of x equal to the integral from -8 to x cubed of sine of t over t squared plus 1 dt. And the first question is just what's a g of 2? So if I was asked this question, I would start by plugging in 2 for x. So g of 2 is going to be the integral from -8 to 8 of sine of t over t squared plus 1 dt. Now, I don't know how to integrate this, but I noticed that these are opposite sides of each other, which is a really good clue that this might be an odd function and the integral might be 0. It is. This is equal to 0 because this function here, which I'm going to call f of t for a second, f of t equal to sine of t over t squared plus 1 is odd. If she asks you a question like this, she might want you to show it's odd. To show the function's odd, you have to show that f of negative t equals negative f of t. Here, f of negative t is sine of negative t over t squared, negative t squared plus 1. Sine itself is an odd function, so sine of negative t is negative sine of t, and negative t squared is just t squared plus 1. And this is equal to negative f of t. But if you see something like -7 to 7 or -5 to 5, right, it's a pretty good bet that it's going to be an odd function and the integral is going to equal 0. Okay, second question, find the derivative. So this is where we have to use the fundamental theorem of calculus. Say, okay, I know when I take the derivative of the integral, I'm going to plug in the variable for t. So I'm going to get sine of x cubed over x cubed squared plus 1. And then since it was more complicated than just x, what do we have to multiply by at the end?
2x, 3x squared.
Right, the derivative of x cubed because of the chain rule. All right, that's all there is to that one. So let's look at the next one. Again, we can always come back to that when you have questions. So this one gives you 6 different integrals and asks you what method to use to integrate them. And if we have time, we'll come back and do all of these, but let's just talk about the method so far. So the first one, the method would be integration by parts. The choices, and I didn't ask you to tell me what you would choose for what, but I'm going to tell you now. This would be integration by parts. Your u would be the natural log of x. Your dv would be x cubed dx. And then you have to find du and v. Okay. This one would be a u sub. Your u would be the natural log of x. The way we can see that is because the natural log of x is stuck inside being squared. And also the derivative of natural log of x is 1 over x dx. So we would be happy with that choice as a u sub. I guess I should underline it. This one is also integration by parts. This one is actually integration by parts twice. But we'd start off with integration by parts, where here u would equal x squared, dv would equal cosine of x dx. This one here, that's also a u sub, right? I think this one's probably, of all of the questions, I think this one might be the easiest one to see. U would be x to the 4th plus 9. I should write u sub, sorry. This one is also a u sub. There's a lot of u subs. Here it would be a u sub, where u is equal to x squared plus 9. This one's like the most ideal u sub because your derivative is exactly 2x. We'd be happy about that. And then this last one, well, I said we had to use all of them, and we haven't used integration by parts yet, partial fractions yet. So this one is partial fractions, but we can see it's partial fractions because we can see that the degree on top is less than the degree on the bottom, and the denominator does factor. And it's not a u sub, right? Yeah. I also actually want to point out one quick thing that I noticed when I was writing these problems. I'll just show. So we'll do one of those. But so I just want to point out that I was going to write down this question, the integral of 2x over x squared minus 9. And the thing about this one is technically you could do it with a u sub or partial fractions. Which should we do? A u sub, of course, right? If you have the choice between partial fractions or something else, usually you want to pick the something else. So don't pick partial fractions unless you have to. So this one here, you could use partial fractions. You should use u substitution. Okay. So then question 3 was do the integral in problem 2a or 2c. I'll do both of them for you guys so you can see both. And then maybe we'll do the rest after problems 4 and 5. So for 2a, we said they're both integration by parts. So we got x cubed times natural log of x. We would let u equal the natural log of x. And our dv would be everything else, would be x cubed dx. Our du is 1 over x dx. And our v is the antiderivative here, which is x to the 4th over 4. So we've got the whole setup. Now we have to rewrite it. So this is going to equal u times v. I'm a fan of kind of writing it all as one fraction. So you can write it as natural log of x times x to the 4th over 4. I might write it as x to the 4th times the natural log of x all over 4. Right, it's still x to the 4th over 4 times natural log of x minus the integral of v du. So it's going to be x to the 4th over 4 times 1 over x dx. And for these ones specifically, when it's integration by parts and you have the natural log of x times x to a power, it's always going to work out this way where once you get to this step here, you have to just simplify the integrand before you do anything else. This is going to be x to the 4th natural log of x over 4. And this here, I can bring out the 1/4, and x to the 4th divided by x is just x cubed. So you make sure for sure that you simplify your integral, right? This new integral, it's supposed to be easier, and it is as long as we do the simplification. And then we'll get x to the 4th times the natural log of x over 4 minus 1/4. The integral of x to the 3rd is x to the 4th over 4 plus c. And you might rewrite this as x to the 4th over 16, right? But that's probably not the big deal here. Okay. Stop me if you have questions. I'm just going to keep going. But do chime in if you have a question. So 2c, which I'm not going to have enough room for here. Let's just do it on the other side. I was trying to leave myself enough room. There's not enough room. Let's do this one. So it's the integral of x squared cosine x. It is also integration by parts, but in this case, the integration by parts, we're going to let u equal the x to a power. So u is going to equal x squared, and dv is going to be the rest. Cosine x dx. If you made the opposite choice, that would not get you where you want to go. Because while choosing u to be cosine, your du would be negative sine. It's not really any different than picking dv to be cosine. Picking dv to be x squared means your v gets more complicated, right? We don't want that to happen. We want the thing to get simpler. So this is the right choice. Also, I'll just remind you of the LIATE acronym, right? The way we're picking u is first we look for a logarithm. I don't see one. Then we look for inverse trig. I don't see inverse trig. Then we look for any power of x is what I'm going to start saying instead of an algebraic term. We look for any power of x. Oh, I see any power of x, x squared. That's our choice for you. So then our du is 2x. Our v is sine of x. Be careful with this, right? It can be easy to get the plus or minus wrong, but the antiderivative of cosine is positive sine. So then this integral ends up equaling uv, so x squared sine of x, minus the integral of v du, which is going to be sine of x times 2x dx. In this point, some people have different views on what to do. I've always liked factoring out any constants, but I think that's actually probably the less good way to do it, because if you factor out the constant, you then have to remember to distribute it back when you find the new integration by parts for this one. So although I would normally want to factor out the two, I'm going to leave it alone. So let's see. We're going to do integration by parts again. Let me use a different color. So for this integral here, we're going to let so you should, if you're doing integration by parts more than one time, you should be making the same sorts of choices, meaning the u thing should be the same type of thing in your light, and the dv thing should be the same type of thing. So u should be 2x, and dv should be the rest, which is sine x dx. Du is going to be 2 dx, and v is going to be, the antiderivative sign is negative cosine of x. So then we've got x squared sine of x minus uv, so 2x times negative cosine of x, minus the integral of v du, which is negative cosine of x, v du times 2 dx. And if you look at what I've written here, I've actually made a small mistake. The mistake is that this integral is equal to 2x times negative cosine x minus the integral of negative cosine x times 2 dx. But then I should be subtracting all of this integral. So I should be subtracting all of this. So be careful, right? When you're doing integration by parts the second time, there's often a minus sign in front of your integral, and that minus sign has to distribute to all of your uv minus the integral of v du. It has to distribute. So let's see what we get. We get x squared times sine of x minus a minus is plus 2x cosine of x. And look what I've got here. I've got minus a minus a minus. So that's minus the integral of cosine of x, 2 cosine of x dx, which is going to equal x squared sine of x plus 2x cosine of x minus 2 times sine of x, because the integral of cosine is positive sine, plus c. Make sure you remember your plus c's on your quiz for your indefinite integrals or for your short midterm, whatever they're going to call it. Right, the plus c's are worth points, so make sure you remember them. Okay. I'll erase the other side here. We have time, we'll come back and hit the other ones. So let's see, problem 4, find the integral from 1 to 3 of x times the square root of x squared minus 1.
And I have a question.
What's that?
I have a question. For like integration by parts, that's when you said like Burke doesn't do it, but you use T.
Oh, I do that when if I know I have to do integration by parts and then I do that when I have to do a u substitution first and then integration by parts.
Oh, okay.
That's when I do that. I just noticed that the limits of integration here are they're not as nice as I meant for them to be. Oh well, sometimes that happens. So these are not going to be, darn, maybe, no, yeah, they didn't. Darn, oh well. I meant for this to be something slightly different, I guess. It's still something we can do. So we're going to do a u substitution. We're going to let u equal x squared minus 1. Du dx is 2x. 1/2 du is x dx. So this is going to become, let's see, so my x dx, that's my 1/2 du. And then the square root of x squared minus 1 is going to be the square root of u, where I'm going to write u to the 1/2. And then our limits of integration, I think we should also change them. So if x is equal to 1, u is going to be 1 minus 1, which is 0, or 1 squared minus 1, which is 0. If x is 3, u is going to be 3 squared minus 1, which is 8. Yeah, I might have to come out slightly different. Oh well. Okay, not everything comes out perfectly. So then this is going to equal 1/2 times the integral of u to the 1/2 is u to the 3/2 times 2/3 from 0 to 8. 1/2 times 2/3 is 1/3. So you get 1/3 times 8 to the 3/2 minus 0 to the 3/2. So our final answer would just be 1/3 times 8 to the 3/2. You can't simplify. I mean, there is some simplifying you can do with this with 8 to the 3/2, but not enough to be worthwhile here. I would encourage you all to not get bogged down with the simple. Like if you get an answer, like or even maybe this is something else, like if this was not 0, don't do any simplifying until you've like done the other problems on the test. And then if you have time at the end, and you really want to simplify something, simplify it. But do all the problems, get as much work on the page as you can, and then if you have extra time, simplify things that you think need to be simplified. But don't simplify things if she's not asking you to, right? That's a way to give yourself an opportunity to lose points and waste time. Okay, let's look at the last one here. Set up an integral for the area of the region bounded by those two curves. And the curves are f of x equal to 8x minus x squared. Oops, x squared. And g of x equal to 5x. And I'm going to do this one without graphing them. Even though we could totally graph these, this is just a straight line. This is just a downward opening parabola. You could not too difficultly graph them. Giles, I would say, so here's the thing, back to your question. So someone asked me, sorry not to call you out, but it's a good question. You shouldn't be, when you do a U sub, you don't have to change the limits of integration if it's a definite integral. I know that Burke encourages you all to. I also encourage you to. I think it's the easier way to do it. But if you had wanted to, you totally could have not changed the limits. And then at this stage, gone back and said, okay, that's going to be 1/3 times, instead of u to the 3/2, x squared minus 1 to the 3/2, then evaluated between 1 and 3. But here's the thing, right? When you plug in the 3, then you're going to get the 9 minus 1, which is 8 to the 3/2, just like we got here. When you plug in the 1, you're going to get the 1 minus 1, which is 0 to the 3/2, just like we got here. So it's really, you're not doing any more or less work by going back. You're probably doing more work going back this way. It's usually easier to just do it this way. So you can do whichever way you want, but all of us are trying to encourage you to do it this way because we all think it is usually easier and less terrible. But either way is fine. Although I will also point out, sorry, one more thing. If you do it this way, like if you don't change these limits of integration, you have to say like instead of this, you'd be like it's still x equals 3 and x equals 1 or something. Like you can't say that the limits are the same even if it's different variables, which is another reason why it's nicer to change them. Okay, so this thing, I want to find the area bounded by these two graphs. So first I'm going to find the points of intersection. So we're going to set f of x equal to g of x. We're going to get, let's see, 5x equal to 8x minus x squared. I'm going to bring everything to the left. Get x squared minus 8x plus 5x equal to 0. So x squared minus 8 plus 5 is minus 3x equal to 0. So factor out an x. So we've got x equal to 0 and x equal to 3. Which means those are our limits of integration. Our integral is going to be the integral from 0 to 3. The only other thing we really have to figure out is which one of these is the bigger function, right? The one that's higher up. And to do that without graphing, pick a point between 0 and 3. I'm going to pick 1 and see which of these is bigger. G of 1 is 5. F of 1 is 8 minus 1, which is 7. This is the bigger one. So our integral is going to be the integral of f of x minus g of x, which is going to be the integral from 0 to 3. Let's see, f of x minus g of x is going to be 8x minus x squared minus 5x, which if they only said set it up, I would leave it right there. But then since the bonus question is evaluate it, let's go ahead and evaluate it because it's not too hard to evaluate. So to evaluate, we're going to simplify. We're going to make it the integral from 0 to 3 of 3x minus x squared. We're going to anti-differentiate. We're going to get 3x squared over 2 minus x cubed over 3 from 0 to 3. Plugging in 3. 3 times 9 is 27 divided by 2 minus 3 times 3 cubed is also 27 divided by 3. And then minus, if you plug in zeros, you just get zeros. So you could leave it like this. You can simplify 27 over 2 is 13.5. 27 over 3 is 9. So 13.5 minus 9 is 4.5. Or if you prefer, you can write it as 9 over 2. That would also be fine. So that's how you do that one. We have a few minutes left. We have 3 minutes left. Would you guys like to see, is there any one of those other integral problems from problem 2 that anyone specifically wants to see? If not, I'll just pick one. If you want to see a specific one, whoever speaks first gets their choice.
Can you do the partial fractions one?
Totally. I had a feeling it was going to be partial fractions one, which is good because that's what I was going to choose too. So yeah, so for the integral of 6 over x squared minus 9 dx, we're going to take this integral, the integrand, right, just the fraction. We're going to factor it because, of course, you have to be able to factor it to use partial fractions. And then we're going to set that to a over x minus 3 plus b over x plus 3. And then we're going to find a and b. So we're going to, I should say, before we're going to find a and b, we're going to multiply both sides by x minus 3 times x plus 3. So we're going to get on the left, sorry, the whole thing multiplied by that. So on the left, we're going to get 6. On the right, we're going to get a times x plus 3 plus b times x minus 3. Personally, I think you should all use the convenient values of x method, meaning here I can pick x equal to -3 to make this part go away. So then I get 6 on the left because there's nowhere to plug in x equal to -3 on the left. And I get 0 plus b times -3 minus 3 is -6. So b is equal to -1. If I plug in x equal to 3, I get 6 on the left. I get a times 6. And I get b times 0. So I get a equal to +1. If you don't like that, though, the other way to do this is by equating coefficients and saying, okay, on the left, I have 0x plus 6. On the right, I have ax plus bx. So that's a plus b times x. And I have a times 3 plus b times -3. So I have a times 3, plus 3a minus 3b. And then you can say a plus b has to equal 0. And 3a minus 3b has to equal 6. And then say that b equals -a. 3a minus 3 times -a is plus 3a. 6, so 6a equals 6. A equals 1, and then b equals -1. Either way is fine, but I think you can all see from just the amount of work I did here, it's easier to do it that way. So always, if you can, pick the values of x that make lots of things 0 so you can find the other things. Finally, we have to actually do the integral. So we have to remember, okay, we're saying that this thing here is equal to this thing here is equal to this thing here. A is 1, b is -1. So this integral is equal to the integral of 1 over x minus 3 plus -1. So I'm just writing -1 over x plus 3. These are both straightforward to anti-differentiate. We get the natural log of the absolute value of x minus 3 minus the natural log of the absolute value of x plus 3 plus c. And then just as a quick aside, you might see people simplify this as the natural log of the absolute value of x minus 3 divided by x plus 3. You shouldn't worry about that, but you might encounter it at some point.